Hello all. In this video we are going to look at basics of arrays and matrices using the NumPy library. So NumPy is a very effective, highly optimized library or module for dealing with arrays and matrices. So if you want to deal with arrays, matrices, linear algebra, my suggestion is you definitely go with NumPy. And all you need is to install it and then to import it. And then you can import everything from it. You can import some functions, or you can go ahead and import it and rename it as np. So every time you want to refer to something, instead of saying numpy array.array, you say np.array, just to make it a little bit shorter. That's quite common in using Python. So here, if you want to create an array, all you need to say is np.array. And then inside the parentheses, you define your array in a bracket and you separate the values with a comma. Make sure that no space between entries, just comma. Okay, it's not like MATLAB. In MATLAB, you can do comma or space. In here, it has to be comma. Space is you're going to get error. And then you can show the entire array in one single piece. You don't need to use a for loop or anything, right? Or if you want to create a 2D matrix, then what you need to do is to separate the data for each row of matrix in a separate bracket. So you see the first row is 1, 2, 3, the next row is 4, 5, 6, the next row is 0, -5, and 10. So each row goes in a bracket, and then the whole matrix also goes in another bracket. So you're going to see two brackets in the beginning and at the end. And so here, this is a 3x3 matrix. And the next one is a 2x3 matrix. You see there are 2 rows and 3 columns. And you can provide also the data type. You say D type, comma, D type, and then provide the type of numbers. So these guys are integer numbers, these guys are float numbers with decimals, right? And then you can show the entire matrix also in a single print command, right? So you can have integers, float, complex numbers, or anything. All you need is this extra piece of option to add to the np command, np.array. If you want 3D or higher dimensional matrices, similarly, what you need to do here is this matrix is basically 2 by 2 by 3. So it has 2 pages and each page is a 2 by 3 matrix. So you see here, this is a 2 by 3 matrix and this is another 2 by 3 matrix. And then they are put together using a comma and then this extra bracket on the left and right. So you're going to see 3 brackets, of course, on the beginning and at the end. The beginning and at the end, and this is a 3D matrix. So again, this guy is a 2 by 2 by 3. That's what this guy is. So it has 2 pages and each page is 2 by 3. And then, or if you want to start from the inner dimension, it's going to be 3 by 2 by 2. Now, if you want to access entries of matrices or arrays, keep in mind, just like C++, the first number is going to be index 0 or location 0. In MATLAB, it's 1. In C++ and Python is 0. So if you want the first number of the array, it is going to be array and in bracket 0. If you want the one element of a matrix, you say matrix and then you say 0, 0. Okay, so that's element 1 and 1 in your matrix. Now, if you want what? If you want several entries of the array or the matrix, what you can do is to use the column operator. So here, let's say if I say, give me array from 0 to 3, what does that mean? It means is entry 0, entry 1, entry 2, and the question is entry 3 going to be included? And the answer is no. It's not like MATLAB where A column B means all numbers from A to B. Here, when you say A column B, it means all the numbers from A but less than B. So the last number you have is B minus 1. So when you say 0 to 3, literally it means 0, 1, and 2. The 3 itself is not included here. Just keep that in mind. Let me show you. So here is array 1, this is matrix 1, this is matrix 2, and this is that 2 by 2 by 3 matrix. You see it clearly has 2 pages. And here is element 1 of array 1, which is clearly 1. Then here, look, array 1, 1 to 0 to 3, you see it only has elements what? 1, 2, and 3, or indexes 0, 1, and 2. The last number is not included. So please keep that in mind about the column operator. What else? Let's say from this matrix mat1, I want to access a block that is first 2 rows and first 2 columns. So I want to get numbers 1, 2, 4, and 5, like you can see here. How do I access it? I say matrix 1, 0 column 2, 0 column 2. Again, the 2 itself is not included. So it basically means 0 and 1 row and column, again 0 and 1. So you can get a matrix block here. Or if you want an entire row, right? So what would you say? Let's say I want the whole 3rd row. What do I say? I say for index of row, I say 2, not 3. Pay attention, we are starting at 0, not 1. So when I say 2, I'm actually accessing the 3rd row. I'm accessing the 3rd row, and then what? Of course, all of the columns. So if I want to say all of the columns, I don't need to say from what to what. I just use a single column. That means all of the columns. But which row? Row 3. And you clearly see that this is my matrix, and this is row 3, and this is exactly what? This is that answer here, as you can see. Look here. This is what? Sorry, this one. This one is row 3, right? Row 3, all columns, which is this guy, and this is the row 3 of course, what? This matrix. That's this portion here. Right? If I want column 1, what do I say? If I want column 1, I have to say all rows but column 1. So what do I say? Let me add that. If I want to get, let's say, column 1 or column 2 or anything, one thing I can say is, so let's add something here. So I want column 1, right? So column 1 means all rows, but column 1 is index 0. So that means what? That means column 1, right? First column. So let's go ahead and add that here and run it. And here is what you can see, this part. You see the numbers are 1, 4, and 0. And if you look at this, this is 1, this is 4, and this is what? 0, right? So this is what? This is first column, 3rd row, a block, an entry, or anything for that matter. And a couple of other things for this column operator that might be interesting to you. If I say 0 column and I don't provide the end number, if I just say 0 column, what does that mean? It means from 0 all the way to end. So 0 column literally means 0 to end. Now, in Python, we don't have the keyword end like we do in MATLAB. We have to know the size of the matrix. But I don't have to know it. Just I need to say 0 all the way. Column means column to the end. So these two are what? These two are equivalent to each other, right? These two are the same thing. And the other thing is, if I say column 2, so I don't provide the beginning number, what does that mean? Again, it means from beginning all the way to 2. Okay, so if some miss the beginning number or the end number of the column operator is missing, that means what? That means it's from the beginning to that or from end to that. So for example, if I say what? If I say rows from 0 to end and what? Column 1, what does that mean? That's actually not column 1. Again, that's the dangerous part. It's not column 1, it's column 2, it's second column. Why? Because I start at index 0. So this is column 2, but all of the rows, right? What about this? This means, again, all rows from 0 to basically row 3, right? Because remember, this means what? 0, 1, and 2, which means rows 0, 1, rows 1, 2, and 3. And what is this guy? This means column 2. So again, that means the second column. So whether I do this in this case, because the matrix is 3 by 3, or I use this, the result of both of them is second column, and you can see that over here. Look, this guy or this one, they are both second column of your matrix, which you can see it here. This number, and this number here. I just remembered I would like to add something for you that you might see here and there, and that is negative indices. Remember, I told you we don't have the keyword end in the Python, but you might see somebody says, hey, what is array -1? And say, oh, -1? What does negative mean? Remember, I said 0 is the first one, and it keeps going all the way to the end. Now, what Python does is instead of end, they use -1. So -1 basically means end. So if I say give me array -1 means give me the last element. If I say -2, it means the second from the end. And if I say from -3 all the way to what? To the end, that means the third element from the end go to -2, go to -1, right? Which basically means the last 3 elements of array 1. And here I ran the code, and you can see that, right? Where my array is this guy, the last element, -1 is -7, -2 is 8, and then the last 3 elements, which is -3 column, is 2, 8, and what? -7. So we don't have end, but we do have negatives, okay? So if you see negative indices, don't be surprised. It's nothing really special. The other thing that came to my mind to say it before I move on is, what if you want, let's say this is your matrix, right? What if you don't want to go for a block of matrix? What if you don't want to go first row, second row, first column, second column? You don't want this 1, 2, 4, 5. What if you want to jump? So you want to keep 1, 3, and then 0 and 10, right? So first and third column, first row and third row. How would you do that? And the answer is, if you do it this way, you're not going to get what you want. So what I'm saying here is, hey, row 1 and row 3, column 1 and column 3, right? You expect this to do the job, right? Because I'm putting the indices I want in this command here. In MATLAB, you do it this way. In MATLAB, you basically say something like this, right? You say go from 0 to 2 with the step of 2, and 0 to 2 with the step of 2, and that does the job. Now in Python, you know that 2 is not going to be included, so you have to say go from 0 to 2, but for 2 you have to put the final number 3 and this, and I'll show you that this is now not how you do it in Python. But you might say, well, let's not use the double column operation. Let's just use directly type in the number 0 and 2, 0 and 2. Would this give me what I want? The answer is no. Take a look here. If I run this, look, this is what you get. And that's interesting. 1 and 10, if you look, it gave you element 1, 1 and element 3, 3. So it did not get you rows 1, 3 and columns 1, 3. It only gave you the 2 corners of what you expected. So if you really want to do that, you have to use the column operator. And for column operator, that is like double like this. The format in NumPy is different. In NumPy, if you want to use double column, the way to go is this. It's the beginning number, column, the stop number. Of course, it's not exactly the stop number. It's really the stop plus 1 that you have to do, and then the step. Okay, so if you want to do it, remember that in NumPy, you have to put the step as the last number. In MATLAB, you do it as the middle number. In Python, it's the last number. So if you want to do it, that block that I told you, you have to do it this way. Look. You have to say go from 0 to what? Really 2. Although I say 3, but that number is 2 with the step of 2. Then go from 0 to 2, what? With the step of 2. So you have to write it this way. And now look what happens if I do that. Here, look at it. Now it gave me 1, 3, 0, and 10, which is exactly what I wanted. So if you want to get a slice like that, this is the way to go, and this is your double column operator. The other thing you have to pay attention to is this is to create indices, not to create numbers. So if you want to create numbers from 0 to 10 with a step of 3 or something, you don't say I want to go 0 column 10 step 3, and 10, you know, 10 is practically 9, not 10, right? If you want 10, then you have to say 11. Okay, so this is just for indices. It is to create the indices that you want for a matrix. If you want to create data itself, right, the numbers are like that, then the way to create equally spaced data is using np.arange and np.linspace that I'm going to show you in a second. And you know what? Let me do it right now before I go to anything else for you and talk about the types of numbers and everything. So this is just for what? This is for indices. Let me say it. This is for indices, not actual numbers, not actual data. Okay, so please keep that in mind. If we want to create actual data, the way we go about it is these two commands, np.arange and np.linspace. And let me tell you how these two guys work. So arrange, when you say np.arange, 0 to 10 is again not really 10, it's only to 9. So it goes from 0 to 9 with a step of 2. Okay, now if you just say np.arange 10, what does that mean? So if you do not provide the beginning number, then the beginning number by default is going to be 0, and if you don't provide the step is going to be 1. So let me add that here. Default begin equals 0 and step equals 1. Okay, if you don't provide them, then that means go from 0 to 9 literally, and with a step of what? 1. So keep that in mind. And linspace is similar, but in linspace, instead of providing the step, you provide the number of data points. So here you go from 0 to 10 with 5 equally spaced data points. And the other thing that you have to keep in mind is this really goes to 10. This does not go to 9. So linspace does include the last number. Arrange, like column operator, does not include the last number. That is another basically interesting thing that you might keep in mind. Let me show you that here. So look here. This is data from 0 to 9, as you can see, with the step of what? 2. If the 10 was included, then this guy would include 10 as well here as the last number. But since it only goes to 9, then you would stop at 8. Right? But let's look at the other one, which is B. And seems like here I have provided it, right? So I said data points from 0 to 5, and then I said format length of B and B. Oh, I see. I needed another thing here. So this one tells me the number of data, which, by the way, I want to introduce to you the command len, which is to give you the length of a vector, the number of entries in it. And then this is equal to, and then what? The B itself. So here we need to add one thing. And I guess now you can see here 5 data points from what? From 0 to 10, not from 0 to 5. From 0 to 10, that is going to be, as you can see, 0, 2.5, 5, 7.5, and 10. You clearly see that the final number is included. Okay, so this one does include the final number. This one does not include the final number. And again, if you want the length of a vector, you can use the command length. So here I got this 5 data points out of it. Right, so linspace, you know the number of data, you don't know the step size. In arrange, you do know the step size, you don't control the number of data, right? Although they are related to each other using a very, very simple formula, but that is the main goal of arrange and what? Linspace. And here, just to show you this other one, I show you this arrange of 10. So you see the numbers go from 0 to 9 here, and I assume I have to comment this out for you. So here that you can see, you see the numbers are from 0 to 9, not 10, with a step of default 1. Okay, so hopefully this part is clear, the arrange command and the linspace command. Now let me show you some other things about the matrix. One is the type command. What does type do? If I run the command type, what it really shows you is which class of data it is. And you see it says class is Numpy n-dimensional array, ND array. So the matrix 1 is an n-dimensional array that we created using Numpy. So type just gives you that. If you want to know the type of data, what kind of data are the numbers inside it, the entries, you have to use .d type, not type. And it's a dot, and it's not the command type, okay? So you're not going to run the command type, which is a built-in function. You say mat.d type. So these are properties of the object mat1 and mat2. And you see mat1 is int 32, of course, because all the numbers are integers, but mat2, where the numbers are floats, you see what? Float 64 bits. Okay, so float numbers are 64 bits, integers are 32 bits, basically, or 4 bytes. So D type, right? .d type is the type of entry data. Type is the class of data. The other important command is shape. For a matrix, you can use the command shape, and shape will give you the number of rows and the number of columns. If you just run .shape, it gives you both. If you say .shape 0, it gives you the number of rows. If you say .shape 1, that gives you the number of what? Columns, right? So this is the number of what? Rows and columns for a matrix. And for an array, again, the command is length of b. In MATLAB, the command is called size instead of shape. And this command is length, the whole word, but just wanted to tell you how to get the type and the length of data or size of a matrix and the type of entries. Now, what about adding some numbers to an array and removing something from an array? Can I do that? Yes. Arrays in generally are mutable, and you can change them, and the size for them is dynamic. So they are not like a static data that you cannot change their size ever. You can always add and remove. And so if you want to eliminate an entry from an array, you can use the np.delete. So you use the delete method from the np or a Numpy, and you pass to it the vector and you pass to it the location. So here is what? Entry 1, and it's not really 1, it's actually entry 2, is this guy removed. So 1 here means entry 2, right? This is the location, not. So this is entry number 2 is removed. As you can see that this number is removed from this, and the result is this one. And then here I go ahead and I can insert something into an array, and I use the command np.insert. I give it the array, I give it the location, and I give it the number. So here I'm saying go to the third location actually, and let me fix this. The third location of array, and add number 100, which you can see that it is added. By the way, when I run these commands, it's not going to alter the original array. You see here, if I have altered the array with the delete command, when I add this 100, this 2 would not appear, but this 2 did appear. So these two commands are not going to what? not going to alter array 1 as well as this insert command. Okay, they create a copy of that and they change that copy. They are not going to change the original array, okay, unless you assign it back to the array. Otherwise, these guys are not going to alter array 1 for you here. Okay, so I assume I have shown you everything here, right? And let me just add this last part for you. Arrays are mutable and they are dynamic, or they have a dynamic size. Okay, just want for you to know that, and you can change everything in them. So hopefully this video is useful to you and you learn very basics of how to work with arrays and matrices. Next video, I'll show you how to perform linear algebra operations, more advanced operations on them. Thank you.